Hi, this will be the second video that I talk about relationship of exponential and logarithmic function. So this video I'm going to talk more details about the relationship of exponential and logarithmic function. So this is the logarithmic function because this is a log to the base e, right? So at first I want to teach you how to find the inverse of a logarithmic function. So as you know that to find inverse, you're going to let the y equals to the inverse of x, right? Y to the inverse of x. So, and you're writing that fy will be equals to x, right? This will be the method that I apply here. So, then you substitute the y, fy, because given fx is this one, right? So you substitute it in, we will come getting a ln y plus 2 equal to x. Right? So you're going to change the x become the subject so that you can get the f inverse here. So y plus 2. So this is the log base e, right? Log base e equals to x. So y plus 2 is e to the power of x. This will be your inverse function, ex minus 2. And which y is f inverse of x, right? Again, I have proved that the inverse function of a logarithmic function will be a exponential function. So if you find the inverse of this, you are getting back the logarithmic function. So this will be the way of finding the the inverse of a logarithmic function here. So firstly, I want to show you that the algebraic relationship. Show the relationship by using algebraic method. Means I just writing by using algebraic. So very simple. For example, you take the fx equals to ln. For example, if I have ln x equals to fx equals to ln x plus 2 and gx equals to ex minus 2. Before I finding the inverse, this is the way of finding inverse. So how if I tell you that fx is ln x plus 2 and gx equals to ex minus 2 without asking you to find the inverse of fx, or without asking you to find the inverse for gx? How do you know that these two functions is inverse to each other? Means that g is f inverse, or I can say that f is g inverse, right? So if you find g inverse, you are getting this. If you find f inverse, you are getting this, right? So how you know? Without finding the inverse function, right? But after you find the inverse function, you know this is the inverse function of this, right? But without finding the inverse function, how you know that these two functions is inverse to each other? By using algebraically. So very easy. You have to show that if this is an inverse to each other, if let's say f inverse of x, you were getting x back, right? Or you said f inverse, composite of f inverse and f, you are getting x, right? The meaning here is, if this is the inverse of this function, your composite function of fg, you are surely getting x. So now I show you how to, if you are not getting x, means this is not the inverse of f, right? So okay, so you have f gx, right? F gx. So f, what's your gx? Your gx will be ex minus 2, right? Ex minus 2. And ex minus 2 is the function, is the input that you're going to put into your fx here, right? Into your fx here. So you have to put ln ex minus 2. This one will be replaced by ex minus 2. Ex minus 2 plus 2. Then you can see that ln minus 2 plus 2, you have 0, so you have ex, and you bring down the x, you have ln e, right? The x you bring forward, and ln e is 1, so you have x. This I show that, you see that your fgx is x. So let's do the other way. Composite of gfx. So you have gfx, right? Gfx, right? So then now your input will be your fx, which is ln x plus 2, right? Ln x plus 2. So you're putting it into your function g. So which is e e. So this function ln x plus 2, you're going to put it here. E ln x plus 2 minus 2, right? So as you know that there is a formula that when you have e ln of fx, e ln, so you are getting back the fx, right? So you try to look at this at the chapter 1, alright? So ln, you are getting x plus 2. So minus 2. So 2 minus 2, you have 0, then you're getting x. Can you see that? Fg, you're getting x. Gf, you're getting x. So this have already shown that g is the inverse of f, and f will be the inverse of g, right? You can I have in the previous video when I talk about inverse function, I got talk about f, the composition of fg. So if the fgx you're getting an x and the gf you're getting an x, so means it's happened to follow these rules here, right? Whereas the inverse, when this is the inverse of each other, they were getting the x. This is the way that you show the relationship of exponential and logarithmic function, right? So they are inverse to each other. So all right, let's talk about graphically, right? The third one I talk about graphically. Okay, graphically will be you have to show that the graph is symmetrical about the line y equals to x here. So you have to draw the graph y equals to x, right? You want yx, you have to using ruler or graph, you make sure that the scale, the scala is 1 to 1. The scale is 1 to 1, okay? 1 to 1. So then you draw a line that are really y equals to x here. So now you're going to sketch the graph into the function here. So in this video, I'm not going to teach you how to sketch the graph for ln and the exponent, and you have to refer back the video that I teach you the technique of sketching the graph. So for the graph of ln x plus 2, okay, you can refer to the video of sketching the graph of logarithmic function. It will be look at the function inside here, right? The x plus 2 have to be greater than 0. So it's greater than negative 2. So means at negative 2 here, there is a vertical asymptote. There is a vertical asymptote, right? There's a vertical asymptote. And you have to, because the graph is x more than negative 2 is on the right hand side, right? So, and this is a positive. So the graph have to be moving this way, right? So they will intercept the y-axis here. Intercept y-axis means x equals to 0, right? So x equals to 0. So you have ln 2. They will intercept at ln 2. So the graph will be going this way. Right? So this will be the graph for y equals to fx, which is ln x plus 2. Now we go for the graph f inverse of ex minus 2. Right? How to sketching the graph of exponential, right? So you can refer to the video. So I slightly go through. It is the graph for exponential. Very simple. If this is positive, you put a negative 2 here. Okay, negative 2. You know that negative 2. So the graph, if this is positive exponential, it will be on top here, right? So the graph will be intersect the y-axis here. So intersect y x0. So y-intercept x equals to 0. So y equals to e to the power of 0 minus 2, which is negative 1. Right? So they will intercept at negative 1 here. So the graph will be going this way. Alright? They will be going this way. So I'm interested about the x-intercept here. Right? To find the x-intercept, of this graph, so the y has to be 0, right? This is your y, right? So it means that ex minus 2 has to be equals to 0. So ex equals to 2. So if you put ln both sides, then you have x. Ln e is 1, so equals to ln 2. What can you find out? Here will be ln 2. So means that here you were having a ln 2. Ln 2 x, the x-intercept. And the asymptote is negative 2, right? If you see that the vertical asymptote is negative 2. And for here, negative 2. This one will be your horizontal asymptote for the exponential function. So the graph will be this way, right? If you draw precisely, you will see that the graph is actually symmetrical, right? It's symmetrical about the line y equals to x. This will be your graph for y equals to inverse of x here, right? Inverse of x. So if you sketch, you see there is the intercept here, ln 2, right? Here also will be ln 2, ln 2. So then they will intercept for this exponential, they will intercept at -1, right? -1. Then without finding what is the x-intercept here, you know this is also will be -1, because they are symmetry, right? They are reflected about the line y equals to x. When this is the graph for y equals to fx, and this is a graph for y equals to inverse of x, definitely the graph of these two functions will be symmetrical about the line y equals to x. So if you talk about relationship by using graphically, very simple. So you said that the graph of fx and f inverse of x is always symmetrical about the line y equals to x. Alright, this will be the properties of relationship of the exponential and logarithmic function. And if we talk about domain, right, domain of f, okay, domain of f. So the domain of f refer to the x value, which will be domain of f will be -2 up to infinity, and the range of f will be -∞ up to infinity, right? If you look at the graph for ln, right, this is the graph for ln, right, ln fx, it will be the y will be -∞ up to infinity. So if you check that, the domain for f inverse and the range for f inverse, they will exactly interchange, you know, because you see domain of f inverse, right? If you see the domain of f inverse, this will be your f inverse exponential function, right? So you see that the graph, the domain is -∞ up to infinity, -∞ up to infinity. And for the range, the range, you look at the range here, the y value here, for this exponential function, is the y value, there are no graph here, right? So it means that the range here is from -2 up to infinity, right? -2 up to infinity. So very simple. If you see that the domain of f will be the range of f inverse, and the range for f will be the domain of f inverse. So this is details of the relationship of exponential and logarithmic function. So you can view the video again and again so that you understand what is actually I trying to deliver.